Enceladus, one of Saturn's moons, is a small icy world that is home to one of the most fascinating mysteries of our universe: the search for extraterrestrial life. This moon is known for its intriguing features, such as its bright white surface and deep cracks with geysers that shoot plumes of water vapor and ice particles into space. But what makes Enceladus particularly exciting is the fact that it has an ocean of liquid water beneath its icy surface, heated by tidal forces from Saturn. This creates hydrothermal vents on the seafloor, similar to those found on Earth, that could potentially support microbial life. In addition, recent discoveries of organic compounds on the surface of Enceladus, including ones that are building blocks of amino acids, have made it an even more promising target for the search for extraterrestrial life. So let's explore the possibility of life on Enceladus and what it could mean for our understanding of the universe. Enceladus is a small moon of Saturn that was discovered by William Herschel in 1789. It's the sixth largest moon of Saturn, and it is about 500 kilometers in diameter. Enceladus is mostly made up of water ice, with a small amount of rock at its core. The surface of Enceladus is one of the brightest in the solar system, reflecting almost all of the sunlight that falls on it. The surface is also covered in long linear cracks called tiger stripes, which are up to 130 kilometers long and 2 kilometers wide. The tiger stripes are particularly intriguing because they're the source of the plumes of water vapor and ice particles that are ejected into space. In 2005, the Cassini spacecraft discovered the plumes of Enceladus erupting from its south pole. The discovery was a surprise to scientists who had not expected to find activity on such a small and cold moon. Follow-up observations by Cassini showed that the plumes were coming from a subsurface ocean beneath the icy crust, which was being heated by tidal forces from Saturn. The subsurface ocean on Enceladus is believed to be at least 10 kilometers deep and has a rocky seafloor, which provides a suitable environment for life to potentially exist. The ocean is also in contact with the moon's rocky core, which could provide the necessary energy and nutrients to support life. Since the discovery of the plumes, several more missions have been proposed to study Enceladus in more detail. In particular, scientists are interested in sending a spacecraft to fly through the plumes and directly sample the water and ice particles for signs of life. While direct evidence of life on Enceladus has not yet been found, the presence of an ocean of liquid water and the potential for hydrothermal activity make it a promising target in the search for extraterrestrial life. In addition to water, Cassini also detected organic molecules in the plumes of Enceladus. Organic molecules are the building blocks of life, and their presence in the plumes adds to the evidence that Enceladus may be habitable. The organic molecules detected by Cassini were primarily made up of carbon, hydrogen, and oxygen, which are essential components of life as we know it. So let's talk about the hydrothermal vents that are considered essential to the potential existence of life beyond Earth, because they create a unique environment that can support a variety of microbial communities. On Earth, hydrothermal vents are known to harbor thriving ecosystems that are not dependent on sunlight, which is a key requirement for most other known forms of life. Instead, these ecosystems are powered by chemical energy derived from the hydrothermal activity. The vents create a chemical-rich environment that provides the energy and nutrients needed for the microbial communities to thrive. The same conditions that create these unique habitats on Earth could also exist on other worlds, such as Enceladus. In fact, there is strong evidence that Enceladus has hydrothermal activity taking place in its subsurface ocean, which is the key reason why scientists believe that this small icy moon could potentially support life. One of the reasons why scientists think that there may be hydrothermal vents on Enceladus is the presence of silica nanoparticles in the plumes of water and ice particles that erupt from the moon's south pole. Silica is a mineral that is formed in hydrothermal systems on Earth, and the presence of silica nanoparticles in the plumes strongly suggests that there are hydrothermal vents on the seafloor of Enceladus. In addition to the silica nanoparticles, there's also evidence of hydrogen gas in the plumes. Hydrogen is a key energy source for some forms of life, and its presence in the plumes suggests that there could be microbial communities living in the subsurface ocean that are using hydrogen as a source of energy. The presence of other organic molecules in the plumes, including ones that are building blocks of amino acids, further strengthens the case for the potential existence of life on Enceladus. The hydrothermal vents on Enceladus, if they do exist, could create a unique and potentially habitable environment that could support a variety of microbial life forms. These vents could provide the necessary energy and nutrients for life to thrive, even in the absence of sunlight. However, much more research and exploration will be needed to determine if the Moon is truly habitable and if there is indeed life present on this fascinating world. Scientists are exploring the possibility of life beyond Earth, with a focus on places that contain similar features to Earth, like Enceladus. If you enjoyed this video, then consider subscribing to our channel so you can get to know more about what lies beyond our beloved home, Earth.